Okay, here's another example of adding or subtracting. X minus 1 over x plus 2, 4 over x squared minus 4, and 6 over x minus 2. So again, we want to make sure everything's factored first so we can determine what our LCD is. We have to find that in order to add these. And I want to check to see if these are relatively prime, so I'll rewrite that. That's just going to be x minus 1 all over x plus 2 plus 4, and we can factor this. That's the difference of perfect squares, so that's just going to be x plus 2 times x minus 2, and then minus, and this is already pretty simplified, 6x over x minus 2. So now I want to construct my LCD, so it has to be something that all three denominators divide into. So I want to write it down so I can actually physically see it. So I'll know the adjustments I need to make. And always look at the larger one. I'm going to have an x plus 2 times x minus 2, because this has got to fit in there, but also I can see that x plus 2 is here and x minus 2 is there, so there's my LCD. So I have to make all these denominators the same. So I'll rewrite this and give myself some room to do my work. X minus 1 over x plus 2 plus 4 all over x plus 2 times x minus 2, and then minus 6x all over x minus 2. And if I look at my LCD, what am I missing here? I'm missing an x minus 2. So I have to multiply the top and the bottom by x minus 2. So any parentheses there, x minus 2. Over here, I'm all set. I've got my common denominator, so there's no problem there. And here what I need an x plus 2. X plus 2, x plus 2. All right. Now I'm ready to put these all over the common denominator, so I'll write this out. You could maybe skip this step, but be very careful with that negative sign if you go right to multiplying these out. But here I've got, just so you see, x minus 1 times x minus 2 plus 4 minus 6x times x plus 2. And that's going to be all over the LCD. I need a ruler because my fraction bars are getting kind of long, so I'd like to keep them relatively straight. So that's going to be over my LCD, or x plus 2 times x minus 2. All right? And I'm going to simplify that, so I multiply this out, and then I've got some binomials here, so I'm going to end up with probably quadratic up on top. So x times x is x squared, so I got x squared. And then I've got negative 2x, and I can write these all out if I want. Negative 2x and negative 1x, and then positive 2, or I can combine those, plus 4. Now watch this negative sign, negative 6x squared, and a negative times a positive is a negative 12x. All over my LCD, and I could write LCD if I want here, because it's going to be repeating that. Okay, so double check. X squared minus 2x minus x plus 2 plus 4, negative 6x squared, negative times a positive is negative 12x. So I double checks that. And then this is going to equal so I've got x squared minus 6x squared is negative 5x squared. Kind of just check those off. So minus 5x squared. And then I've got negative 2x, and negative x is negative 3x, and negative 12x makes negative 15x. All right, and then I've got, so that takes care of those, that takes care of those, 1, 2, negative 15x. And 2 plus 4 is 6. And it looks like I can factor out at least I don't like the negative sign, so I'll factor out at least, oh no, I can't. Because that's it. I was hoping that would be a divisible number, but it's not, because I don't have a number that goes into all those, so that's pretty much it. So, and I'll write out my LCD, x plus 2 times x minus 2. That's it. Yep. And one of the restrictions on my domain, x cannot be any value that makes the denominator 0, which would be plus or minus 2. That's not too bad. Okay? So these problems have a tendency to be a little bit longer because of all the LCD work you've got to do, so be aware of that.